Is this what success looks like? We'll find out soon enough. Let's save this because it's got a star here. And let's go down into configure. So it's synthesized down to here. Still got the X because of something, but now let's double click on the configure design initialization. We got this. Make sure we get on this guy. Double click on this guy. We got this guy. Got this guy. That's what we want it to be. Say OK. And now we generate bitstream. Yeah. Okay. Let's see. No, let's 6 out of this. Let's do Control S. Get that top star gone. Double click on generate bitstream. All right. So while he's generating, just do one more quickie of what we're going to be doing here is that we have a test that I used to previously. I filled the RAM, and then I read the RAM back, and that worked. So now I'm no longer filling the RAM. I'm reading it, which should be the PROM contents. I'm reading, let's see, the full 64K bytes now in 32-bit word chunks. And so that's working through this address. Let's do a quick look at this LS address base right here. So this is how I set up, and I'm addressing it. So I'm treating this kind of like as an array, 32-bit values. I'm starting at address 60 million hex. And so then I start incrementing the address index offset. And as I increment that, it's working through the memory, and I'm comparing every location with II. And if they are one and the same, that's cool. If they're not, I bump a fail count. And then later on, I wait till like putty's all working. We've got this little polling loop going, which is from the bare metal library, which is someday I'm going to start playing around with a few more things in it, I think. And got the bare metal library, and it's going through whenever there's data that's from putty. So a key press. That's going to fall down through here. It does that stuff, which I'm not interested in. But let's see. So right here is interesting. So it'll give us a printout of the fail count. And that should be hopefully as well 0. If not, then it'll be something like last time we had it at 4,000 failures, 4K failures. So we print that out with this statement. So we create the message with sprint, and we print it out with MSU hold T. And then we have a little loop which just works through some of the initial values here, just to print them up on the screen. Let's go with double that. Why not? Get a little bit more. So we change that, and then it'll print out the value every 8 values. It'll hit a carriage return, and yeah. So I'm hoping I'm hoping the fail count is 0, and then we can be done with this. So we're going to do a Control S. We're going to left click on the hammer. And anyone jumping in on this last success story, there's other things on more detail on how all this stuff fits together in the earlier failed attempts. So it's compiling here. Yeah, so he's ready to go. But Libro, great. Click. Oh, not again. I got so confident. It's the exact same error. So it's the same error. It's the same error. Oh. How dare I ever be confident when dealing with this? Okay, once again, I failed. If anybody out there knows how to get past this, I'd really appreciate it. But for now, I think I'm gonna take it as one last fail, and I'm gonna move on with life. So I think, so I did. I was able to generate this with 32K values, but that doesn't make sense to me on why I can't have 64K bytes. I should have, 256K bytes should work. So it's a puzzle. Anyway, sorry for the fail.